Okay, so I am on page 232, and what we're going to do this time is we're going to try to find the intersections of some lines. So if you remember, I'm doing this as if you didn't just watch the video. It's like the next day for me, new shirt, whatever. But if you remember, there's a couple of things that can happen in three dimensions. You can have lines that intersect, obviously. You can have lines that are parallel, which is again kind of obviously right because a plane is in three dimensions, just a two-dimensional object in three dimensions, and you can have those things happen in a plane. Like on your paper, you can draw lines that intersect. You can draw lines that are parallel. In three dimensions, though, we add this option where, like, instead of staying parallel all the time and not intersecting, lines can be skew and not intersect. So, like, random line on the ceiling, random line on the floor, probably not going to be parallel, but they're also not going to intersect. So those are skewed. So let's see if we can do these problems. So I want to find the intersection of the lines given below if it exists. Otherwise, explain if they're parallel or skew. All right. Your dream scenario is that they're parallel. So I'm going to take a look at the direction vectors. So let's pull those off. So your vector here is, ew, what is going on? Let's get out of there. All right. It's -2, 1, 3. And your vector here is 4, -1, 2. So definitely not parallel because those are not scalar multiples of each other. So now our question is, are they skew or are they intersecting? So what we're going to do is we're basically just going to ignore the z component for now. And we're going to solve as if it's two-dimensional, the x and y kind of system that we get. So if you remember, what you do is you set up a dummy variable, right? So I'm going to say that this is like x1, y1, z1, and this is x2, y2, and z2. And so I'm going to ignore the z's and just cover them up and do that two-dimensional problem. So this is, let's write it down. So ideally, we're going to solve this system. We're going to solve x1 of t equals x1 of v, and y1 of t equals y2 of v. We'll solve that for t and for v. So what that'll do is it'll tell us the times. So you got like two things moving at like different rates or whatever. We're going to find the times when we're going to find the times when the x coordinates are the same and the y coordinates are the same. So like it's possible that we're going to be at the exact same point because the z's will be the same. It's also possible that when the x's and the y's are equal, it's like one thing is on the floor and one is on the ceiling. So after we find when the x and y's are equal, we're going to plug that into z and see if the z values are equal. And if those are equal, then they're, all on the floor. If they're not equal, then one is on the floor, one is on the ceiling. So I'm going to use a calculator to do this to kind of like speed it up. So let me share the calculator screen with you, and I will do that. Okay, so you should be looking at a calculator screen, hopefully. I'm going to store some things. So I'm going to say x1 of t is -9 minus 2t. y1 of t is 5 plus t. x2 of, so I store everything as a function of t because that's how it's kind of like given. But what you can do is once it's stored as a function of t, you can make it a function of r, w, whatever. So that's why I'm doing this. And y2 of t is 6 minus t. Okay, so I want to solve the system. So I'm going to do menu 3, 7, system of equations, 2 equations. I'm going to solve for. My variables are t and v. Okay, here we go. You can use the var key to speed this up like quite a bit. x1 of t equals x2 of v, and y1 of t equals y2 of v. So I'm going to solve for t and v. I get -3 and -4. So now the question is, when t is equal to -3, what is z1 of -3? When v is equal to 4, what is v1, v2, what am I doing? when v is equal to 4, what is z2 of 4? All right, so I need to figure those out. So I should have defined them. So z1 of t is going to be 13 plus 3t, and z2 of t is going to be equal to -4 plus 2t. All right, so I need to do z1 of -3, and I get 4. I need to do z2 of +4, and I get 4. All right, so these intersect. They intersect, and now I want the intersection point, right? So if I do x1 of t, y1 of t, z1 of t, such that t equals, so for x1, y1, z1, it needs to be the t value that we solved for, so -3 gives me that. Now let me go up here and edit this. So you can save a lot of time by editing things that you've already entered rather than like typing them over again. I see people waste so much time typing things again when they just didn't need to. All right, so I'm gonna change this. So I solved for it as v, but v was a dummy variable, right? So like I'm gonna just use t equals 4. I could, and you see you get the same point, like you better because we're saying that they intersect. So let me switch back to the notes. And then I will show you, like, because you're probably wondering, like, all right, well, what if you had done y and z? I'll come back to the calculator and show you what would happen if we had done that. So back to the iPad, back to the notes, got a screen mirror, blah, blah, blah. Here we go. Okay, so when we did this, we got t equals -3, and we got v equals 4. And then we did, let me see where I am spacing this. Okay, so kind of like skipping a lot here. Well, I'm not skipping anything. I'm doing it on the calculator. Like, you should also be able to do these by hand, but it's just a system of linear equations, so I'm confident that you can do that. Okay, so once I got this, z1 of -3 gave me 4. z2 of 4, what? It's confusing because it equals 4, so my brain wants to like jump. Equals 4, therefore they intersect. And where do they intersect? So if we test, well, not test, but if we find, woo, knock that off. What did we do? So I did x1 of -3, y1 of -3, and z1 of -3. And when I did that, I got something that I did not make a note of. Let me check my calculator again. I got -324. -324. And that's also x2 of 4, y2 of 4, z2 of 4, -324, which is guaranteed to happen because we know that they intersect, right? So that's what it means for them to intersect. So one of the things you can do if you want to like get a sense of this, hopefully you're a better artist than me, but if you can draw like rectangular, oh my gosh, I started off so well with like that one. Let's go across. I'm aware that I don't do this right. So what's happening here is like both of the lines happen to be on like this face, right? So they're like somewhere in space, but like they're on the same face of like a rectangular prism, sort of. Or they're really just in the same plane. Intersecting lines are always in the same plane, like they just have to be. So I said I was going to go back and do this again, as if, because I have it all set up in the calculator, I'm just going to like do it and show you what would have happened. So what if, I got to switch to the calculator again. So so I'm not gonna lie, I pretty much always just do X and Y and then like see if the Z values are equal, but we didn't need to do that, right? So I have all of my things defined. So I'm gonna do menu 3, 7, system of equations, I'm gonna solve for T and V again. What if I wanted to do Y1 of T equals Y2 of V, and Z1 of T equals Z2 of V? And I solved that and I get this, and then I would just check the x coordinates. So it doesn't matter which two you decide to do, as long as you do it consistently, it's going to work out. So don't be afraid to like, basically if you have to do it by hand, don't be afraid to do the easiest of the systems. I always do that. So let's take a look at the next one. So I'm probably just I'm gonna knock out this page right now, then I'll come back and do more in another video. So they're gonna be basically the same. So step one is we want to see, are they parallel? Because you're living the dream if they're parallel, because you don't have to like solve that system or do any of that stuff. So vector is going to be -5, -1, -4. And this vector, these are the direction vectors, so they're the coefficients of t. Those are not scalar multiple of each other. So now we're off and we're going to go through the process. So I'm going to define these things, or at least make it clear. x1, y1, z1, x2, y2, z2. I feel like a good set of notes would make these skew. So let's find out if these are actually skew. I feel like they should be. So we're going to solve. I'm going to vary it up for you just because I don't want you to think you always have to do x and y. If I were doing this by hand, I think I would have done x and y. There's like some gross numbers no matter what you're doing, like 30. They're not gross. They're just like bigger than 5, I guess is what I'm saying. So I'm going to solve, because you get to pick. I'm going to do x1 of t equals x2 of v, and then I'll do z1 of t equals z2 of v. All right, so I'm going to use the calculator again because I'm trying to like not spend 1,000 years on this. But you could just do it by hand. I mean, when you do it, it's not really that bad. All right, I'm going to start a new problem. So doc for 1, it's going to be calculator, and now I'm in 2.1. So all of my vars are just cleared out. Whereas if I go back to 1.1 and press var, it's filled, right? So that's why I did that, so that when I'm checking my work for problem number 1, I can just go back to problem number 1 and not like have to retype everything. All right, let's knock these out. x1 of t is 36 minus 5t, y1 of t. So another thing you can do is you can hop on GeoGebra and graph them. So like the previous example where they intersect is a good one to take a look at because you can like see it. And I think seeing is believing. x2 of t is 15 plus 3t, y2 of t is -9 minus 2t, and z2 of t. So you should be doing this. Like you should be trying to keep up. You're not going to be able to because I'm typing, but practice with your handheld, and the more you practice, the faster you'll get. All right, our system. So I'm going to do menu 3, 7. My variables are going to be t and v, and I'm going to do. So you can get these from the var key. I recommend it, but it's just faster for me to type them. Press tab to get down there. z1 of t equals z2 of v. Okay, so I'm solving that. I get t equals 6 and v equals -3. I'm gonna actually write that in the notes. I'll like show the notes again at the end, but you should jot this in your notes right now. So t is 6 and v is -3. So this will prevent me from having to like mess around later. All right, so that's when x and z, so the 2 x coordinates are equal and the 2 z coordinates are equal. So that means like maybe our lines intersect, or maybe one line is like on the wall to your right and the other line is on the wall to your left. And we found the times at which they're like at exactly the same x and z. And now the question is y the same? If y is the same, intersecting. If y is different, then they're just skew. So I have to find y1 of 6 because x1 and z1 are associated with t and t is 6. And then I have to find y2 of -3 because x2 and z2 are associated with v and v is -3. So we get -3 both times, which means these intersect again. So if you remember, I said good notes would make a skew problem here. but these aren't skew. So are these bad notes? I don't really think so, but the diversity of solutions probably could be better. So let's actually find the intersection point. Or I'm going to jot that down. I'm going to say y1 of 6 is -3, and y2 of -3 is also -3. It's a little unnerving that the like second thing keeps being the same as the parameter value. That's a coincidence, but I don't know why it's happening. Well, coincidentally, I guess. There doesn't always need to be a reason. So you're probably right now saying, why did you do 2s? I don't know. There we go. It's because I was like extemporaneously talking about something like the randomness. Here we go, such that t equals 6. Okay, so I get that. And let's modify this. So make that a 2. Make that a 2. So on the handheld, the fastest thing is delete type 2, and then -3, and we get the same point. So I'm going to say 6, -3, 2. So I'm going to say intersection point is 6, -3, 2. Which means, again, if we drew like a rectangular prism, they would both be on one of the faces of the prism. Rectangular prisms, by the way, like don't need to be oriented the way that your brain is probably telling you to orient them all the time, where like one face is parallel to the floor. Well, 2, I guess, are parallel to the floor. Like you could just roll it around, right? Just like randomly, like if you throw dice, you could take any of those positions. So like it doesn't need to be horizontal and vertical. All right, so this is what I've written in my notes. I use a calculator to solve this. So maybe I should like make a note of that. Let's say calculator, so that we remember that at some point later in life. And I'm going to do it on this one too, by calculator. And so I'm not going to draw the picture because same picture again. All right, here's to hoping. I don't know why I'm hoping for this, but here's to hoping that these are skew. I think they will be, because I can't imagine that I wrote a set of notes where every answer just intersected when that's like a miracle. On the other hand, I can definitely imagine doing that. So like I don't want to be able to imagine it, but knowing me. So I'm pulling off vectors. No way those are scalar multiples of each other. Actually, it was really close. They were almost scalar multiples, and then that z component is different. So that's kind of interesting. All right, so we're gonna label things: x1, y1, z1, x2, y2, z2. And what haven't we done? We did xz, we did xy. Let's do yz. So there's no reason to do this. You could always do x and y. Like that's what I usually do. I just want to give you the option. And I imagine at home you're like thinking, what if? So I'm trying to cover all the what if scenarios, which is not super easy. C1 of t. I guess I already did this on the calculator though. I don't know. Who can remember? Okay, so we're gonna grab our calculator. Let me note that I'm gonna use a calculator. By calculator. Okay, I'm gonna take the calculator, I'm gonna solve it. I feel like this is gonna be skew. Feel it. Seems like it should be. I'm gonna start a new problem. Doc for problem. Enter. Let's define these. So x1 of t is 12 minus 5t. y1 of t is 3 plus 4t. z1 of t is 16 minus 7t. There we go for that. And then x2 of t might be faster for you to copy and paste like the previous ones and just kind of edit them. Experiment with that. See what you decide. Let me know. Let me know in the comments. Which like y3? Come on, man. It's z2. Look at that. That's it. As soon as your mind wanders, you think you can multitask, but you just cannot. All right, what are we doing? So let me check these. 11 plus 5t, 6 minus 4t, 13 plus 6t. Good. 12 minus 5t, 3 plus 4t, and 16 minus 7t. Also good. All right, so here we go. We're going to solve a system. Menu 3.7, system equations, t and v. And it's going to be y1 of t. Remember, you can use the var key. Also the cursor. I'm super good at leaving the cursor like right in the way. And then z1 of t equals z2 of v. Okay. Ooh, fractions. All right, I'm gonna write this in the notes so that I don't have to bounce back and forth. You should also jot this down. So t is -3/2 and v is 9/4. So that's interesting. I mean, it's not any more interesting than the other ones just because they're fractions and we haven't had those yet. I'm like, ooh, it's exciting. All right, so now I used y and z. So I have to test x's. So x1 of -3/2, right? Because x1, y1 and z1 are associated with t. T is -3/2. Check x1 of -3/2. I get 39/2. Crazy. X2 of 9/4 for the same reason. Y2, Z2 go with V, and V is 9/4, so 89/4. All right, so these are skew. So let me just like confirm that for sure. X1 of t, Y1 of t, Z1 of t. So the only times when their Y and Z components are the same, their X components aren't the same. Which means if we solved a different problem and found the only times when their X and Y components are the same, their Z components won't be the same. If we find the only time when the third thing that can happen happens, which is like, I guess X and Z are the same, their Y components won't be the same. And maybe I should do that to just like hammer that home. Or maybe this video is really long. I'm not really sure. Okay, so I get that. And then change these to 2, 2, and 2. I'm really hoping I'm getting this right. 9/4. Okay, so there it is. When their Y and Z components are the same, the X's are not the same. Kind of interesting. So I'm gonna write that fact down. So actually, let me like switch back because this is not. It's not as obvious as just writing the ordered whatever. Okay. I guess I have to stop the share. I couldn't get it to just bounce to the iPad for some reason. So now you get a giant version of my face. Okay, it's back to the small version of my face. Okay, so I should have been writing that though. So I'm gonna say x1 of -3/2 is and not y1. X2 of 9/4 is, and let me refer back to my calculator. If you've been doing it on your handheld, you just have that information, you can do it. Should be beating me to these notes, 39/2, and this will be 89/4. Okay, so I'm gonna say the lines are skew, because they are. So if you want to explain it more, you can say like the only times when Y and Z are equal. Oh my gosh, what even just happened there? Let me delete that. I can't even delete that. What is that? Maybe I can cut it? Okay, now it's gone. I hope other people saw that because, now I have the keyboard up. It's freaking out. What is going on? I don't want to start typing. It wanted me to start typing. When the only times when, okay, so Y and Z are equal, X is not equal. So this is a situation where if you, I'm not gonna be able to draw this, but it's like you have, maybe if I draw like a very exaggerated one. It's like, what order am I even drawing this in? Right, so this is our thing. What happened was you have one line here, and then you have another line that's like just over here, just doing its thing, like whatever. You have two lines and they're just on like opposite sides of this thing. So they're totally skew. All right, I am gonna stop this here and I will be back to do more with you in the next video.